Hi everyone. So, symbiosis at work. That's what we call it. And in this session, I'd like to talk to you about something really practical. How did we arrive at this symbiotic model of working between expert researchers and AI? I'll tell you the story of where we started from about 3 years ago, and then at the end, I'd like to finish on a question for the industry. Where are we heading from here? We've already heard this morning that, well, change is here. We need to embrace it. We need to get more architects, for example. Okay, but where does that leave researchers? So it will be great if everyone can pitch in at the end, and let's see where we get to. Okay, so sorry, I need to press this one. Right. So what I'd like to cover in this session, there are really four things. First, I'll tell you about the problem we started with. So we didn't have sort of a theory of how to use AI, but we started with an actual real life problem. We were contracted by the European Investment Bank. We needed to process about 9,000 pages of text. And we needed to find a way how to accomplish that quickly and robustly. The second point is why just a general reg was not enough, and how did we solve that problem? And then we talk a bit about symbiotic working, which is the consequence of the sort of first 2 points. And as I said, we'll finish on the talent pipeline question. As I'll explain, our model works because of expert researchers. So if we're now enlisting AI to do various tasks, how will we have expert researchers 20 years from now? Okay, so we began with the scale problem. To begin with, we were contracted to do a manual piece of work, which we very quickly realized that it's not doable within the time, budget, and complexity. We had 90,000 pages to process. And that was due diligence documentation for all the projects the European Investment Bank funded over a decade. Right, we could have, the immediate answer would have been, let's just get an LLM, chatbot, get researchers to use the chatbot to speed their work up, something perhaps like Copilot. But we very quickly realized that that has a major limitation. While it increases productivity, you still have to process documents more or less one by one. It still takes quite a lot of time. So what we did is came up with a process that solves scale to begin with. So let's imagine a different type of working, not with AI, not where we're helping researchers by providing them with productivity tools, but we produce kind of a horizontal way of working where it is the AI doing the work, with researchers intervening at particular points in time, and with tasks being split into very small tasks that the AI then does, and I'll talk to you about that in a minute. So developing this kind of horizontal pipeline, that is immediately scalable. Once we get the pipeline right, then that can process a lot of things quickly and robustly, and the key is getting that pipeline right. And we call that a directed approach. And it's directed because we're getting AI or various AI models to do very bespoke things and very granular things. We're not sort of shoving it into a model and expect miracles at the other end. Right, so we did start with, I have not moved my slide. There we go. So we did start with the need to process a large volume of data securely, and that's very important. We couldn't just send it to any old model. And robustly. Right. So we've discounted the possibility of using just sort of a productivity aid in the form of a large language model. So we went to a RAG. And we went about designing a RAG in kind of a traditional way by subcontracting developers. We've discussed the specifications with them. They've developed the sort of framework infrastructure. We used it on this project. It was great. We've produced what we needed to produce in a short space of time. And the client was ecstatic to the point that they recommissioned another piece of work. They had been convinced that we will find very little information. The topic that we were researching for them was one of very, very low incidence. So in a traditional approach, you would have sampled the pages or documents in some sort of way, and then manually looked at the sample, and you would have deduced some conclusions based on that with all the caveats attached. We were able to do it comprehensively, and the client was really surprised that, oh, actually there's quite a lot of information. Using this kind of approach, we were also able to do sort of qual to quant, whereby we were able to do time series analysis, trying to pinpoint what sort of other occurrences could be perhaps associated with some of the changes in the contents of the documentations on the topic that we were researching. So we found that it worked really well, as I said. But we then found that, okay, here's another project that we could apply this to. Wait, it doesn't work. Definitions have changed. Data models have changed. What might have been a theme in the first project became a more granular sort of variable in a second project. So what do we do now? Do we then contract developers again to develop a new reg, to modify this reg? And we've said that that's not feasible, right? We have a scalable solution that can I guess, execute research quickly on a large number of sources, but that process itself is not scalable if we depend on developers having to reinvent the wheel or change the wheel every time. So what we've learned is that every project indeed needs tailoring, and that is easier when the researchers and the people doing the tailoring work hand in hand. Because, in essence, we're doing research. We're doing robust research at scale, at speed, and we don't have the luxury of having to talk to developers, the developers coming back, etc. So, here's Symbiosis. What does that look like? As I said, it's a direct fit process. And it happens sort of at the cutting edge of delivery. So what we found that works best is actually data scientists and developers working with expert researchers who know exactly what good looks like, who know exactly what to do, what not to do, who have the experience, who have done these types of projects themselves many times, and they direct data scientists and developers in making changes to the process so that it fits the exact needs of the projects that we deliver. And this approach relies on agents. It relies on prompts that undertake specific tasks. And I've mentioned already within sort of a horizontal research pipeline that at each point we are embedding AI models. And it's not a general purpose tool. It's a tool. The process is general purpose, but the sort of the way we make it bespoke is we make it bespoke so that it really matches the precise needs of each project it is deployed on, and it's just an algorithmic process, but it is also fast moving. Development really happens in hours or days, because we're sitting in joint teams, in multidisciplinary teams, where the data scientist speaks to the researcher speaks to the data scientist, and we're modifying things as we go along in an iterative way. And I'll just give you an example. On one research project, the prompt base to deliver this project was over 12,000 rows. Now, of course, that's not 12,000 rows of text being sent on every API call, but it is 12,000 rows of rules, definitions, etc. that researchers have come up with to guide the model. Where this particular project, I can't go into any major details, but it required a very high accuracy data extraction from company house filings for about 2,500 companies, and creating a robust, correct data set. And as you'd imagine, there's a lot of variation in how company accounts are submitted, tables, text, etc. There might be errors in there, and we require that level of explanation so that we remove the discretion of the model. The model does not have discretion to decide. The model can do things. Researchers decide what it can do and what it cannot do. And that's really what Symbiosis is. It's an AI process driven by researchers, and that can be modified in near real time, where researchers define the rules, the outputs, refine the definitions, while data scientists implement them. Now, what's important is that it's not, as I'm kind of stressing, it's not a handover, let's hand over research to tech. It's really the opposite. Let's use the advances in tech while maintaining the human expertise in maintaining the robustness by applying the human expertise to the process. It's still a human process. It's just that some of the junior level or a lot of the junior level tasks are now being done by AI. And really, going back to my example about 12,000 lines, it really is like training, or like giving the best analogies, like briefing a junior researcher. So we wouldn't tell a junior researcher, go find me the themes. We would tell them, go find me the themes. This is how you find the themes. This is what is a theme. This is what is not a theme, etc. So we're really treating the AI as a junior researcher and giving them all the support it again needs to make the correct decisions and make the decisions we want the model to make, or the various models to make, in the correct sequence in the correct context. And as I've said, what the researcher brings to this process are the definition, the rules of evidence. How do you treat edge cases? A lot actually of our 12,000 rows is about treating edge cases. But it also, and of course, the view of what good looks like. And that, I think, is very, very important, because AI models don't know what good looks like. They're sycophantic and all that, and they will present things in a positive way to you. But it's us that know what our clients need, not the model. And we need to guide it so that we do generate the insights that are robust. And of course, the data scientists that deliver the data scientists, the developers bring the technical implementation, testing, automation. They know what an error is, and they know how to deal with error handling. They know how to build models or processes that use models in an appropriate way. They know how to build agents and all that sort of stuff, which researchers don't really know. And I've mentioned earlier, it's an iterative process. It starts with researchers. Tasks are defined, then outputs are tested, failures are inspected, then we have refining of rules, testing again, and so on, until we get to a place where it works, and we get to a place where we are confident that when we deploy this process over thousands of records, it will consistently produce the same results according to our rules. Now, that doesn't mean that we don't need to do quality assurance on the finished results. I mean, I think it's fair to say that we could think about it in terms of upfront assurance. The pipeline is built, it's assured, it does what it thinks it does. But then, of course, we always need to check the results. We cannot just blindly trust that once it's been deployed, it has done it in all instances, because there is a degree of randomness there. Our accuracy levels are between 94 and 97%, but we've not been able to go higher than that. But then again, I guess this is just a general comment of when working with AI. Some people tend to, and one of the presentations this morning touched upon this. Some people tend to think, well, it's bad because it's not perfect. Well, I think if, for example, we accept that intercoder reliability of about 80% is okay, then an AI model that produces results with a consistency of about 90-something percent, perhaps that should be okay as well. So we have a tendency to compare AI to the perfect, or some people do anyway, but we shouldn't. We should compare it with what's the alternative. The alternative is not perfect. In my example about the company data process from company's house, well, the alternative would have been to have a team of junior researchers trawling through scanned PDFs for possibly months and picking out digits or numbers with 7-8 digits and putting them manually, pasting them in or typing them in to an Excel. Now, what's the level of error in doing that day after day? Right. This is a really important point. I keep talking about researchers and technical folk working together happily. They don't speak the same language. They not only do they not speak the same language, they don't think the same way about issues. For researchers, things that are important, completeness, evidence, definitions, validity, etc. For example, a process that misses part of a data set will be unacceptable. You can't go to the client, well, we've processed 95% of your data. And actually, we have had those kind of discussions where our developers were saying, oh, this is great. It works on 94%, only 6% error out. That's great. Well, no, from a researcher perspective, well, that's not great, that's bad, because we need to process 100% of the sample or of the data or whatever. For data scientists, it's all about often it's a lot about iteration. It's a lot about the journey. It's a lot about continuous improvement rather than, yes, it works or no, it doesn't work. We I guess, perhaps me, see things more black and white. It either works and it's fit for purpose or it isn't. While some developers are more sort of flex. It's sort of a continuum. So it's really important to get on the same page, to understand what good looks like, to understand what an error is, to understand how do we come together to make sure that we're all on the same page. Just this December, we had a conversation, a team meeting, and we were discussing, we have built a new pipeline for processing on a particular project that needed to be implemented in January. And we've finished the year with the thought that it's ready to be deployed. Great, everyone was happy, we have the pipeline, it's ready to be deployed. January, well, let's deploy the pipeline. And the pipeline was deployed, and we found that the error rate is about the accuracy rate is about 60%, which is nowhere near acceptable. So then a discussion ensued, well, wait, it's ready to be deployed. The developer team, well, yes, it's ready to be deployed. In that, we have the infrastructure. We can press the button, it's live on the infrastructure. It works, it doesn't work well, but we have to train it, we have to tune it, we have to, etc. While people on the other side of the table were, well, wait a minute, it's ready to be deployed. That means that it's going to give me the accuracy I need. So what my point is, we're also sort of I'm not presenting here like a done deal, like it works perfectly every time. It doesn't. It's a journey. It's a work in progress. But I'm just pointing out what are the sort of pitfalls of this way of working. I think I've covered most of the points on this slide. Yes, I think what's important is shared standards, shared understanding, discussion, and actually not assuming that you actually are talking about the same thing and sort of going into more detail than you otherwise would think is necessary. Right. One important point here is that we've not 3 years ago said, okay, we're going to build this horizontal pipeline in this way. We have all the answers. We didn't. We got a project, we started working on it, and then we experimented and saw what worked, and then built incrementally. There were 3 things that made this possible for us in our context. One of them is we actually started from the question of scale. We need to do a lot fast and well. Which then drove us to think perhaps a bit outside the box of how can we achieve that in our circumstance, which then pushed us down this road. The second is that we traditionally are analytics company. So we already had multidisciplinary teams. We already work in data science and so on. So it was it wasn't that big a leap to sort of understand what can be done. So, and that came to our advantage. And the last one is an organizational point. We're a small company, we're a small team. There's hardly any bureaucracy, and decision making takes place very close to the actual delivery. So it's very easy for us to decide, you know what, we're going to change direction and we're going to do something else. We've done this twice when we were very close to sort of committing to building platforms in a different way, and then we pulled the plug last minute, saying, actually, given the change, how the market is changing, that's not going to work. So I think what we do, and this model of symbiosis does need to be sort of thought of in the context in which it came about. And I think this is sort of my last slide before I move on to what does this mean for the industry. But where has this taken us? We are now sort of moving forward and going into the world of research apps versus research pipelines, and trying to embed our knowledge into apps that perhaps clients can use versus us using sort of filling with pipelines every time in this manner. But symbiosis is still the name of the game, because now we're having researchers involved in application development. Because it's the same problem. You want something that does good research. You don't want, it's sort of not the other way around. We don't want to build a platform. We want to do good research. And a platform is just a means of getting there. So it's still about robustness. It's still about the rules and so on. So it's still about expert researchers driving the process rather than tech driving the process. Okay, so one thing that I haven't really very clearly, sorry, I didn't realize I didn't move the slide. So there. So I've talked about three things: scalability, or needing to scale, our expertise in data science, and I forgot what the third point was, but never mind. I've not mentioned the fourth point, which is, well, there are expert researchers. There are expert researchers in this room, and that is key. But the question then is, what happens in the future? Our model hinges on there being people who know what good looks like, who have the experience, who have done it, who have done many of the tasks manually, who have built careers in this field, starting from sort of junior researchers and so on. So we know what good looks like. Now, the advent of AI is mostly affecting junior roles. There's fewer junior roles in other industries as well. There's some references there. But we're hiring data scientists, not necessarily junior researchers, so that we can train them, because we need people who can implement those sort of rules into systems rather than people who do the actual work. So, so what does that then mean for the industry? How will we be able to have a good sort of cohort of senior researchers in X years' time, if now sort of the cycle is kind of broken? I mean, perhaps I'm a bit apocalyptic here, and it's not as bad as I'm making it sound, but it's still a valid question to ask, sort of how do we protect what we have? How do we protect for because the other choice is handing over to AI. We're not developing new experts, we're not developing new expertise, and then are we just gambling on the AI will do it, the AI will know what's good? I mean, it might do, I don't know. I don't know, but it's a valid question to ask and to talk about. And this is what I think I'd like your help with and your thoughts, because this, I think, is not just for our industry, but for many industries of this nature. This is a moment of change. And we heard earlier, like, companies should hire architects. I completely agree with it. We're doing the same thing. But then that just makes my point. So what about the researchers? And Right. And the last point I'd like to make, even with, okay, we do hire junior researchers. How do we train them? I think I've noticed with people we work with that perhaps there's a somewhat inappropriate use of AI at the junior level, maybe not only, but AI is great at executing. It should not be used to replace thinking and replacing judgment. And what we find, many people outsource thinking to the AI that's telling them good or maybe what they want to hear. And it's a catch, because you would know, if you really know what you're talking about, then AI might be useful, because you would know, you know what's good and what's bad and what and how can you use what you're being served in a very positive way, using very complicated terms sometimes. But if you don't, then then how do you know? How do you know to judge that something is appropriate or not? So that's my kind of second point. Other than we're not really hiring new juniors to train, or we're doing that less. The second thing, even when we do they also, how much of their thinking do they outsource to the AI? So I was suggested to have an answer for what we do. I kept thinking, and I don't think I do. So I think it would be great. I'm very happy to answer your questions about the presentation, but I think I'd like to sort of leave the rest of the time for any sort of musings and ideas on this particular point, because I'm convinced that not many people are thinking about this. So thank you.
Thank you, Zsolt. I guess maybe then I'll ask you a question which you may not answer, and therefore perhaps anyone could answer, which is, it's reassuring for the researchers to know that there's a future for researchers here, even if there isn't for new junior researchers. But researchers are kind of broad church. There's a lot of different types of researchers with different skills. Do you have a view on which skill sets are going to thrive in this new world? And which researchers or which skill sets are going to be required to transform into the new world?
I think it's not necessarily about research. I think skills such as, I'm not sure whether it's a skill, critical thinking, being able to basically do the judgment, I think are going to be a lot more needed than the ability, and attention to detail, because I think there's sort of I think that's important, critical judgment and attention to detail, because you need people who are able to basically stand up to the model, stand up to the AI, to be able to say, have the confidence to say, no, that's wrong. So I think it's more about that. I think, perhaps ethnography, anthropology, that sort of area is going to still be more sort of suited, or perhaps the modernization will be a bit slower than in other fields, observation and that sort of stuff. But I think in our experience, both qualitative and quantitative will be sort of equally affected. I think my personal opinion is that sort of the boundaries between quantitative and qualitative research will start to fade. That's anyone else who wants to jump in, by all means.
Yeah, Katie.
To offer a vague answer as a person who's come from a vagueness, the question about being researchers is actually one that kind of keeps me up a bit at night. And I think the answer is something in what you were just saying, that I think critical thinking and indeed data savvy are skills all of us need now. It's not a question of what you need to do in your working life, in your private life. Everyone needs to get more savvy with data, which requires analytical skills, which requires understanding the difference between quantitative and qualitative analysis. So I think the notion of kind of a ring-fenced junior researcher as a role might cease to exist, but I think we will see people developing those data savvy skills, and as they progress through their careers, moving into the research field or the insights field, whatever we call it, at a senior level, not necessarily having come from the typical background that we've known in the past. And we already see it. A lot of the senior leaders in client organizations
are no longer coming from insights, they're coming from marketing. And I think that will trail through. How that works out and how we really ensure that quality of data analysis starts across, kind of spreads and truly becomes democratized, not quite sure. But I think broadly, it's everyone needs to develop those base level skills.
I think I agree. I'll add one more point. I think this has been made today as well. Being reticent about AI, it doesn't work, and being gleeful about, I found something about this particular model that it's not as good as people say. I think that's very short-sighted, because it is here to stay. As you were saying, billions of pounds or dollars, whatever, are being invested in it. So just pretending or wishing it not be here, I think it's not a good idea. So learning to work with it proficiently and understanding its issues in a critical way is really, I think it's really important.
Okay, we've also have a question online, but we're going to have to end it there. So I will make sure that the question online gets to you so you can answer, but we do have to move on because we're running a bit behind. But thank you very much, Zsolt.
Thank you.